Yeah, thank you very much for the introduction. I'm Ruben Bridgewater, and obviously you've seen that error before as well. So what we always have to deal with is perfect. Okay. Yeah, so we always have to deal with errors, actually, and obviously also human errors as we face them all the time. We make mistakes, that's fine. We just have to know how to deal with them in those cases. And as a consultant, I'm often seeing code where people really struggle dealing with errors. In general, error handling in JavaScript seems to be quite difficult opposing to other languages. And one of the main questions is obviously, why is that so? Well, JavaScript, as an asynchronous language, does not provide you with the same stack traces, for example, as other languages do. You do not have the information right at hand where you called your function. Instead, you have different call stacks in there, which you cannot use for debugging. And there is more. For example, in JavaScript, you can throw anything instead of an arrow. And that makes debugging even more difficult because you lose a lot of information if you're doing that. And people sometimes are not even aware that they run into these problems. So let's dig a little deeper. So this is a very simple example. Most of you have obviously seen that before. It's old-style callbacks, you know, and people did not do any error handling in here. It's like completely silent. No matter if this call would succeed or not, you would not know about it. And you would not get notified if it worked or when it finished and all these things. So it is pretty bad. And we pretty much overcome callbacks, right? No one nowadays normally uses callbacks. What we do is we use promises. And promises are cool. They are a good new language feature, or relatively new still. And nevertheless, people still struggled implementing promises, at least the raw promises as they are. Because then here we create a new promise chain. Like it seems like you deal with most errors, but then again, the second call, the write file call, is a completely new one. And this is on Node.js, so you will get a notification in case this would not succeed. And you get like an unhandled rejection error, which is pretty bad because you did not deal with that rejection. In the front end, if you do something similar, you would not get any notification by default. It's just completely silent. All your errors are eaten away. And this makes your life, when you debug, really, really hard. You have to invest a lot of time to actually find out where your error originated from, if it is actually really the thing you're looking at right now, because maybe there are like follow-up errors that would pop up just because something else worked wrong originally. And all these things are really difficult to deal with. Then we have the promise constructor. And the promise constructor is something most people also struggle with. We use them to implement, for example, a promise-based API on top of a callback-based API. And people just do not know about all the side effects in the promise constructor. For example, if you fail synchronously in the promise constructor, it will immediately reject, which is good. But in this case, this function, I don't see the slides. OK, I cannot point on anything. All right. So it doesn't work. OK. The assert input would sometimes just fail synchronously on top. And this function does sometimes return a promise, sometimes it would just throw an exception. So you're in Zalgo and you do not know how things really work or not. And this function could actually even never resolve. You get a promise back, and it never does anything. This could happen. You could have an uncaught exception in the end because it has sync API with a side effect after rejecting, and you did not stop executing your code. You would not know that this is actually really connected with each other in most cases. So let's get to a little bit more real-life examples, because these were more a little bit, specifically made to show you some obvious defects. The primitive errors that I spoke about before. So this is something where people took an API, had a database call, and they promisified it on their own. And now, they, in case of an error, what they do is they reject it with a new error. But this time, it's a string instead of using the original error they received from the API, because when you have a string and you concatenate it with an error, even though this one was an original error with a stack trace and maybe extra properties like error codes and so on, you lose all of that extra information by doing that. So normally, you should just stick to the original error that you received. If at all, you could create a new error and wrap the received one into that as an extra property and return that one. That would be an alternative. Then here, people did not listen to any error. Like, first of all, they only say, okay, it's either 200 because we received some data after doing a database call, and there was at least one entry in there. Or they say, I didn't find anything because I expected an error, as it seems. And then they just say, there was no entry. We say it's a 404. If that's really good API or not, let's keep it at that. But the main problem is the catch part. They just ignore the error. They don't even log that error that they would receive from the database call. And it could have had multiple reasons why the database call failed. Some might be about bad request error, so you had bad input originally, and they just log some generic information and return to the user 500, which is very likely not always true. It could definitely be a different error, and you should always make sure to return the proper error code, and also to log as much information as you can instead of just ignoring the error completely. Otherwise, you just spend way too much time on debugging your application, and you are not only wasting your personal time, but also money from the company you're working for. Then, when you when you test applications, we want to have a good coverage in our tests, in our code, right? And when we do that, when we test our code, we often only test the good cases, the happy pass. So people have an expectation, what would be the return value of your API call, and test for that, and it works in their test, so everything's fine. Turns out, if you only do that, you miss a whole lot. And in production, your application will very likely fail because you did not think about all those error cases that exist as well. So please always make sure to test both sides. It's just as valuable and important to test explicitly all the edge cases. Sometimes you might have thought your API works correct, but the implementation is completely faulty because you did not think about the edge cases that are possible there. Then this is a code that I had to review personally in a company, and this is a pretty, but I don't know, it's really weird what is going on here. So they have an async function, and we have a try-catch, an auto-try-catch, where we then validate the input synchronously. Okay, cool. Let's just go through it step by step. We do the synchronous validation, and then we end up in the auto-catch, and we manipulate the original error message from that validation error and say it could not do things plus the error message. Okay, and then we call rollup with the input. Wait, did we actually? A rollup means you normally were just hitting the database and you now have to take something back because something might have gone wrong. But you did not even call the database so far. So there is no reason for calling a rollback step either. And this is going to very likely fail. And the function will then reject on the rollback call. So what you receive as an error on top is something completely different from what you would expect. And now you lost all your information that you wanted to look at. And it's pretty bad. Now, with the inner try-catch, we then do call the database. And we also catch the error again in place. And we manipulate the error message and say it's the inner error. And we attach the original error message. Now it's something really weird because you check if that error is from a specific class and then you add a property to it and say it's that specific class, pretty much. which is a little bit weird. I don't know, I would just keep it in that class and all is good. Now we rethrow that error, so we end up in the outer catch, manipulate it again, and it's super weird. Instead, what should be done is just have a top validate function without any try catch, because the outer layer should normally be able to handle that, and then run the database call. And normally you should not even have any try catch there either, because you have a top layer and that normally deals with that. And then it's all good. Your code is very simple, very straightforward. All you do in this function is validate input, await db create input. That's it. This is how that function should normally look like. Very, very simple. Rejections. So I already spoke about unhandled rejections. And these are two examples where people struggle seeing that they actually end up in an unhandled rejections in some cases. So on the left-hand side, I personally find it more straightforward to see, because you trigger two promises, you execute two functions, they both reject, and then you call try, await A, await B. So it seems like you await both and you handle both errors. But actually, as soon as the first one that you await fails and it is a rejection, it would end up in a catch call, and you never await B in that case. So if B also rejects, which it obviously does, and then that would be an unhandled rejection. On the right side, it's even more tricky, because that's actually Node Core PR. So someone opened a PR to change it to this code. There was a different example, and it's just one word missing, await. Because here, we call do things, and in the try, we return foobar. Foobar is an asynchronous function, and we return a rejected promise, which is fine. But the problem here is, if you don't await it before you return it, then it would never end up in that try catch. It would then end up in the next upper layer, because you return a promise that is then later on rejected. All right? That's what's happening. That's why the try catch cannot catch that case here. And we end up with these wonderful messages from Node Core, which tell you that there is a mistake in your application. Now, when we still work with callbacks, all of these would normally end up as an uncaught exception, and that's totally fine, because you can then start fresh from zero, and you don't have any problems with your application after restarting, because normally your application has some kind of state or something like that, and then you don't end up in any problem. No, let's not only talk about the bad parts, though. Let's go a little bit deeper into patterns that you can use to really simplify your life. It's not difficult to just stick to them, but they really improve debugging in Node.js a lot, as far as I can tell. So I start always with a simple error class. Normally, I would say, especially in JavaScript, it's better to have no inheritance, but here for error classes, you do want that. So we have our global error class, that is the application error, and then we extend from that different other error classes that are more specific to what you're actually doing in that step, because you want to have different layers where you handle your errors. So one layer would be, for example, a database layer. Another one would be a REST API, where you have to deal with errors. Another one is where you have outgoing errors from your application to another application or another API, whatever that is. And all of these have very specific error cases, and we are able to already provide a couple of information up front. So we extend our user-facing error here and say we want to have, for example, a bad request error. And then with a bad request error, that's obviously a 400, just like a not found error would be a 404. So you have that as a property on that error instance always available, and you don't have to attach anything when creating that error otherwise anymore. It's already available. On top, you only want to do something like throw new error, whatever your error class is in the end, and attach everything right into the constructor there. And that's why I also have an options property here. So in case you want to have, like, I don't know, more information about the user that just called the request or something like that, you could then attach extra properties, whatever is necessary in your application. It's very specific to your application. And then you are just able to receive that. Don't do anything later on, when you have to extend the arrow class, because then you have to do it explicitly everywhere, and you might forget it. Actually, you could even go so far and validate that you expect some specific properties being set or not. That way you always know it's done right. Let's wrap that up, just as a to memorize it properly. We want to have application-specific arrow classes, and we normally validate that input to make sure everything works fine, at least until we deploy it to production. And we also move all those arrow classes out into a separate module that we publish in a private repository. That way you're able to easily import that module and can test against the application error. And you always know if I have an application error, then it is somewhat attached. I threw that explicitly. This is something that your code threw. Anything else would be an error that you do not know about. It's something unexpected. And that's pretty cool. So we have an only source of truth by using such a module. And we attach, obviously, more information there. And you always have it right at hand. Otherwise, we might get errors like these that are very valuable to the user and also to you debugging your application. Right? So a little bit former, I spoke about error handler layers. So in these layers, we have to really make sure that you only handle your errors in these places. Often, people wrap everything in a try-catch. Each function has a specific try-catch, and then you do some error handling there, and you rethrow the error again, which is super weird. Why do you actually do that? It's super simple. Like, if you use async await, code is pretty straightforward, and it would bubble up to the next handler, to the next try-catch that is actually able to deal with that. And that's what we want to do. So we want to have very specific places to deal with those errors. Cool. Let's have an example for that. Here it's Express. So Express is still used by more than 60% of the whole ecosystem, which is a little bit disappointing out of my perspective, because it does not support a lot of new language features, such as async await. So what I have to do here is to actually use the global arrow handler from Express to use the async function, then wrap my call into a try-catch, and call next with my error in case an error occurred. That is not very user-friendly, I would say. And in the global arrow handler, you hopefully now see why the arrow classes that I've just created earlier on are very straightforward to use. You just check for an instance of a user-facing error, because when we have a REST API, we normally expect that we send something back to the user, and we only want to send those back. If it's a database error, that should be completely transparent to the user. They should not know about these. So now, with that instance, we can immediately say, okay, it's the status code that we attached originally to that error. We don't have to think about it anymore. It's already there. And we also send something back like an error code, which can then be translated on the front-end side. That's significantly better than sending an actual message right away. Otherwise, you send more data over the network, and translations will become more difficult. Everything else that we did not expect, so if it's not a user-facing error at this point, even if it is an error of our application error, is something that we did not expect in this point. So that's why I'm going to send a 500 back in that case, and log as much information as possible. That's super important, so you have enough information later on to debug your application. But the code itself is very straightforward, very simple, and there is probably very little that you actually have to write elsewise in this function to deal with your errors. Now, the same example with Fastify, which does support async await, and now actually the upper function is significantly nicer to read, because here you can just await your statement right away. You do not need a try-catch, and if you throw inside of that function, it will then be recognized in the global arrow handler, which is pretty cool. And now we can do the same error handler logic as before. So that's good. With the databases, it's a little bit more tricky. So mostly, each database is very specific to your application, and I don't have a concrete code example because of that. What you do want is to, for example, have a fallback mechanism in case one of your database calls fail. Let's say you had a network outage, and you have a database center A, and you have a database center B that are not physically connected. And now in data center A, there was a failure, and you realize that you would just redirect the same call immediately to the other database center, get the call there, hopefully at least, and then return it to the user. So the call takes a little bit longer because you have that fallback mechanism, but that's still significantly better for the user in most cases, at least if it's done in a still acceptable time. Outgoing requests. So this is a code that I wrote a while ago when I had to deal with the Facebook Graph API, and Facebook had a horrible error in their code where they were sending back a specific Facebook error code 1200 that said, temporary send message failure, please try again later. That happened around about 25% of the time. And that was a pretty bad user experience. And I had to make sure that our users would actually still receive the requested information. And therefore, I was just retrying the request a couple of times with a little sleep in between, and I tried it in higher intervals after a while. So this would not be a great user experience, but as long as they get any response, it was still better than nothing. That's why retrying here is good. Also, as you see, the validate function at the top of the async function, because if the input would have been wrong, malformed, then a top layer error handler would normally catch that, because you have the functions that you just call after each other, they're normally all async, and then it would be caught at the top layer. They just bubble up the errors. So Node.js does provide a few util functions as well. And I'm going to talk about a few of those. And I just implemented something recently. But let's go into the util.promisify. I spoke about that earlier, that you struggle often with the constructor from promises. And sometimes you still need that, because you are still using an API that only supports callbacks. That's fine. We have a lot of code, and it's not always possible to invest the time to refactor it right away. So using util.promisify will completely help you out here, and you don't have to manually promisify your code anymore. It's very valuable. Please use it instead. So that's the example. Here you have the former one, which is a little bit more complicated, because you have the promise constructor, and if you use util.promisify, it's very simple. Should be very straightforward. You understand the code. Unhandled rejections. Here, this is probably the biggest problem with promises in general. And async await does still use promises underneath. It's just a little bit of sugar on top of the promises. And Node.js was always very unhappy about the promise spec, how it's implemented. And just recently, we implemented something where you, as a user, are able to choose between different modes what should happen if you have a rejection that is not handled right away, which means in the next tick. And what happens is your process is not going to exit as the deprecation warning says. It is just going to throw an exception, so it turns an unhandled rejection into an exception that would then normally end your application, because that's what happens regularly with uncaught exception. And then you can start over, which is pretty good, and you have all the stack trays available, especially in combination with zero-cost async stack traces. This is something very new as well, and you have it in Node 12 plus new browsers in case you're working with front-end stuff as well, in Chrome at least, because the VA team did an awesome job here. We have a rejection, obviously, a little bit deep down after a couple of function calls. And as we know, we always lose the information where our code was actually triggered, right? So this is the worst part about JavaScript. Turns out, not anymore. This is super, super huge. Please have a very close look at the stack trace, because here, you obviously, the async calls, async 1, async test, including the line number, you have all the information there from where you awaited your promise. And that is very, very important. I highly recommend to refactor your code to use as much async await code as you can. If you do not do that, you will lose a lot of valuable debugging information. And let's summarize everything that I was just saying, because these rules are probably relatively important. So use the arrow classes, then implement the abstraction layers. You only need those abstraction layers. Don't do any in-place error handling. It's just distracting you from what is actually going on. You often make mistakes, and you only have to deal in very few places with your errors. Make the messages as expressive as possible, and do not manipulate them afterwards. If you receive an error from a foreign API, you can wrap it in an own error afterwards if you want that, because you want to attach extra information that is available for you, but don't manipulate the original error that you received. Use util.promisify and other Node.js error handlers. You have more promise hooks, actually. There's also something like the promise constructor is able to have a dead zone, which means any code executed in there, you will not know if it fails or not. Because as soon as a promise is settled, which means it's either resolved or rejected, it can still continue in the promise constructor. You still can run more code in there, and it could even call resolve or reject again. But you do not know that this happens. With the multiple resolves hook, which exists in Node.js, you can then listen to that and at least log that. It's only a warning, so you could it sometimes helps debugging your application. And make sure that you return proper error statuses and error codes to the user, not something weird, because you are actually also one of your users. Thank you very much. I hope you enjoyed the talk. I hope you're